Question 1, Part A. A baker baked a total of 300 pies to sell. The graph shows the number of each type of pie that was sold. How many banana and lime pies were sold altogether? So what we're looking at is we need to find the banana and we need to find the lime pie. But before that, we need to figure out how many pies is one gap. So we have one gap, 2, 3, 4, and 5. So 5 gaps equal to 20. One gap is equal to 20 divided by 5. And this will give us 4. Now we know what is one gap. We just need to figure out what is the banana. So the banana is above 40. So we have 1, 2, 3. So banana is 40 times is 40 plus 3 times 4. This will give us 2. Then for lime is just 1 gap above 20. So that means lime go to 20 plus 4, which is 24. So that means banana plus lime go to 52 plus 24, and this will give us 70. There you go. So question 1, part B. What was the total number of pies left unsold? So we need to get all of the different number of pies. So for apple, we look at 60, and then we have number of gaps 1, 2, and 3. So that means apples equal to 60 plus 3 times 4, which is 70. Then for the bananas, it is 3 gaps above 40. So 40 plus 3 times 2 will give us 52. The next one is cherry. Cherry is 1 gap below 40. So cherry, that be 40. Minus 4, this will give us 36. Then for lime is 1 gap above 20. So lime go to 20 plus 4 equal to 24. And then lastly, we have pineapple. So pineapple is 2 gaps before 60. Sorry, that's not pineapple. Pineapple is literally just 60. Oh, you see over here. Pineapple, this line, 60. Pineapple is 60. So how many pies are left? So we can just minus off. So pies left go to 300 minus, and we just minus everything. So minus 72 minus 52 minus 36 minus 24 minus 60, and this will give us 50. There you go. Question number 2. Mr. Johnson was paid for working as an assistant at the rate shown in the table. He was paid a total of $646 for working 58 hours last week. The rate for the first 50 hours was covered by an ink blot. How much was he paid each hour for the first 50 hours? So we know the total is $646, and we don't know the first 50 hours. So that's what we're looking for per hour, right? However, we can find the additional hours, which is basically in this case, because we know the total was is 58. So that means the additional hours is 50 minus 58 minus 50, and this will give us 8 hours. And that means the additional total will then be 8 times 12. This will give us, therefore, the first 50 hours paid will then be equal to 646 minus 96, and this will give us $550. Since the first 50 hours is $550, that means 1 hour, or the first 1 hour will then be equal to 550 divided by 50. This will give us $11. So the rate is $11 per hour, not 40 or 50. There you go. $11 per hour. Question number 3. Mrs. Lim has black, purple, and red markers. The number of black markers is 3 times the number of purple markers. 1/10 of the markers are red. What fraction of the Mrs. Lim markers are black? So according to this statement, where the number of black markers is 3 times the number of purple markers, so let 1 unit be number of purple markers. So that means the black markers will then be equal to 3 times 1 unit will be 3 units. And it says here that 1/10 of the markers are red. Since red is equal to 1/10 of the markers, that means the purple plus black, basically total minus red. The total will then be just one whole minus red 1/10, and this will give us 9/10. Then do we know the purple black? This will be in fractions. So purple plus black in units is equal to, so purple is 1 unit plus black is 3 units equal to 4 units. So if 4 units is equal to 9/10, so this is purple plus black units, then 1 unit will then be equal to 9/10 divided by 4, which is equal to, in this case, 9/10 times 1/4, and this will give us 9/4. So 3 units which is the black, equal to 9 over 40 times 3. And this will give us 27 over 40. There you go. So that's the answer, 27 over 40. Question 5, part A. A rectangle is divided into 6 parts. A, B, C, D, E, and F. D is a square and is 1/6 of the figure. Triangles E and C are identical. Which two parts were added to form half of the rectangle? Okay, so if you were to look at D over here, it's 1/6 of the figure. So D over here, 1/6 means this one square, if we multiply it by 6, this would then be equal to the whole figure. That's what we see over here. And then at the same time, we also know that C and E are identical triangles. So that means they have the same height. That's what we see over here. And also the same base. That's what we see over here. And the thing is that since we know that this comprises of 6 squares, that means the base and height of C and E are actually the same. So in a way, they are half of D. And now we look something like this. So let's say, let's 1 unit be area square D. And we know 1/6 of figure is equal to square D, which is 1 unit. That means 6 out of 6 of figure is equal to 6 times 1 unit equal to 6 units. Then from there, we can in a way calculate. So that means E over here is basically half of 1 unit, which will be 0.5 unit. Then we know that D plus E plus F is equal to half of the figure, since the height of half the figure is the same as the top half. Okay, so we know that DF is basically half of the figure. So which means that for F, it's equal to half of the figure, is half times 6 units, is 3 units. So F is basically half of the figure, 3 units minus 1 unit minus E, which is 0.5 units. And this will give us 1.5 units. So since F is equal to C, that means C is equal to F, which is equal to 1.5 units as well. What about B or A over here? Since B is a triangle with the base the same length as the top half length of the figure, top half of the figure, that means it's half of the top half. Essentially, B is equal to half of the half times 3 units, it will be 1.5 units. Therefore, A will then be equal to 3 units minus 1.5 units minus 0.5 units. And this will give us 1 unit. So from all the calculations that we've gathered, which one will give us half? So in this case, B 1.5 and F 1.5. Because we know that half of the total is 6 units. So B plus F is equal to 1.5 units plus 1.5 units, which is equal to 3 units, which is half of the figure. Right, there you go. That's the answer for question 5A. Question 5B. Which two parts were added to form 5 out of 12 of the figure? Since he wants to get 5 out of 12, if want to get 5 out of 12, that means total units is from fraction is 12 units. And okay, to solve 5 out of 12, what I did was I changed square D to be 2 units. Because if we were to go back to part A, our total was 6 units. So in order for us to get the denominator to 12, we need to make the total as 12 units. Then we just calculate everything else. And we just need to find which parts, if we add together, becomes 5 units. And from here, we see that B and A is a perfect match. So in this case, we can just say A plus B is equal to 3 units plus 5 units, which is, 3 plus 2 units equal to 5 units. So A plus B in fractions will then be equal to 5 out of 12. So there you go. So it's A plus B. Question 6A. Jared is 5 years old now. His sister is twice as old as him. His brother is 8 years older than his sister. How old is his brother now? Give your answer in terms of Y. So Jared is equal to 5Y. So his sister is twice as old as him. So that means sister equal to 2 times of Jared, which means this will be 2 times of 5Y, which is 10Y. Then his brother is 8 years older than his sister, which means brother is equal to 8 plus older than his sister. So we know that is 8 plus 10y. So how old is his brother? It's basically 10y plus 8 or 8 plus 10y. Okay, there you go. That's the answer. Question 6, part B. What was the total age of the 3 siblings 2 years ago? Give your answer in terms of y. So we want to know the total age now. So we just calculate everything, which is Jared plus sister plus brother. So Jared is 5y, sister is 10y, and brother is 10y plus 8. And this will give us a total of 25y plus 8. So 2 years. So one person 2 years ago, we need to minus 2 years. So for example, if I'm 10, my age 2 years ago is equal to 10 minus 2, which is 8. If me and my brother total is 20 years old, then me and my brother age 2 years ago, basically 20 minus 2 times 2 is 16. So therefore, we have a 3 person 2 years ago is minus 2 times 3, which is equal to, need to minus 6 years. Therefore, total age of 3 siblings 2 years ago. If you made the mistake of just minusing 2, you're very close. So you just need to multiply by 3. So 2 times 3 is 6, so we minus 6. And this will give us 25y plus 2. Okay, there you go. So that's the answer. Question 7. The figure shows 3 boxes XYZ and a 50-gram weight on a balance scale. The average mass of the 3 boxes is 140 grams. The mass of box X is 40 grams. What is the mass of box Y? We know from this picture, it's a balance. Then we want to find the total first. So the total is basically the average times 3 plus 50 grams. So the average of the 3 boxes is 140 times 3 plus 50. This will give us 470. So one side of the scale is equal to 470 divided by 2. This will give us 235 grams. So the question says the mass of box X is 40 grams heavier than box Y. So that means box X is equal to 40 plus box Y. And the left side of scale is equal to box X plus box Y. Okay? And we also know that the left side of the scale is 235. So that means box X plus box Y is equal to 235 grams. Then we also know that box X is 40 plus box Y. So 40 plus box Y means box X is equal to 40 grams plus box Y. So 40 grams plus box Y plus box Y is equal to 235 grams. So we minus 40 grams on each side, and that means box Y plus box Y is equal to 2 box Y minus 40 grams. So that means we are left with 2 box Y equal to 235 minus 40 grams is equal to 195 grams. So 1 box Y is equal to 195 divided by 2. This will give us 97.5 grams. So there you go. That's the answer for box Y. Question 8, part A. ABC is an isosceles triangle. AB is equal to AC. DEF is an equilateral triangle. AB is parallel to DF. Find the angle W. Right, so how do we find angle W? Oh, you see over here in red. So angle W is actually part of this figure over here. But what is this figure? DHBG. So there is a hint. AB is parallel to DF. So that means this AB in blue is parallel to DF. That's what you see over here. I'll put it in green and make it a bit larger. Since they are both parallel, so I see over here, that means DG over here is also parallel to HB, which means that DG is parallel to HB, which makes this a parallelogram. So now we know that HBGD is a parallelogram. Then we can just find out angle HBG. Angle W equal to 180 minus angle HBG. And since angle HBG is part of the triangle ABC, that means angle HBG. So that means angle HBG, which is part of the triangle ABC, where AB is equal to AC. That's what we see over here. Would then be equal to 180 minus 56, and then we divide it by 2. And this will give us 62 degrees. And since we know this is 62 degrees at one side, then we can find W. And we wrote down what is W, right? So angle W is basically 180 minus HBG, which is in essence 180 minus 62. This will give us 118 degrees. And there you go. So that's the answer, 118. Okay, let's go to part B. So part B says, circle the words that describe DHBG correctly in the following statement. DHBG is or is not a parallelogram because DH is parallel to GB. So earlier, we know that HBGD is a parallelogram, or DHBG is a parallelogram, because since AB is parallel to DF, that means DG is part of DF. It's also parallel to HB. That's what we see over here. And that means this will then be a parallelogram that I'm going to highlight in red. However, it is not a parallelogram because DH is parallel to GB, because there's no proof that DH or even DE is parallel to CB. Therefore, DH is not parallel to GB. Question 9, Part A. PQRS is a rectangle. The length of PS is twice the length of ST. The ratio of the lengths ST, TW, and WR is 1:3:1. The perimeter of the unshaded part of the figure is 56 centimeters longer than the perimeter of the shaded area, TUVW. The ratio of SA, AB, BR is 1:3:1. Find the length of AB. Question 9, Part B. PQRS is a rectangle. The length of PS is twice the length of ST. The ratio of the lengths ST is to TW is to WR is 1:3:1. The perimeter of the unshaded part of the figure is 56 centimeters longer than the perimeter of the shaded area, TUVW. Find the area of the shaded part. Alright, so I have put down the different lengths of the different parts of this figure or rectangle over here. So the only one that you need to know is this PS is twice the length of ST. And the thing is that since ST is 1 unit, therefore PS is equal to 2 times ST, which is basically 2 times 1 unit, equal to 2 units. Be straightforward. So now we want to find the this part. The perimeter of the unshaded part of the figure is 56 centimeters longer than the perimeter of the shaded part area TU, V, and W. So the red lines represents the unshaded part, and this includes this unshaded part, this unshaded part, and this unshaded part. So just to see clearly, this red outline over here is the unshaded part. So what about the shaded part? The shaded part is basically this, and this. So then how do we calculate from here? Since EU, UV, and VW is found in both the shaded and unshaded part, we can remove them. So we can just remove them like this, and like this. So that leaves us with, so essentially for the shaded part, red, we just calculate. So if you calculate all the shaded part, so 1 plus 2 plus 1 plus 3 plus 1 plus 2 plus 1, and this will give us 11 units. So for the unshaded part, so this is without TU, UV, and VW. So unshaded part without TU, UV, and W, it is essentially just 3 units. However, from the question, it says the parameter of the unshaded part of figure 56 centimeter longer than the perimeter area of TUV. This means that the unshaded part minus shaded part is equal to 56 centimeters. Okay, so we know the unshaded part is 11 units. So 11 units minus 3 units equal to 56. This will give us 8 units equal to 56. So 1 unit will be 56 divided by 8, and this will give us 7. So now we know 1 unit is 7. What is the next part? We need to find the area of the shaded part. So the thing is that if you were to look closely, okay, so it will look something like this. We have half of the rectangle PQRS, and then we need to minus this green part. The thing is that the green parts over here is actually just the left side of the rectangle over here. So essentially, we have the red triangle minus the green rectangle, and we will get the shaded part. Okay, so how do we do that? First thing is, we can find out the half of PQRS rectangle. So it's half times what is the PQRS rectangle? So it's over here. So it's length times breadth. So in this case, the length over here is 2 units times 7. And then times the breadth, it is 1, 3, and 1, which is 5. So 5 times 7. And in total, this will give us 245 centimeter square. Now to get the left side rectangle, it is basically just length times breadth, which in this case is 1 unit, then times bracket 2 units, and this will be equal to 98 centimeters square. So now if you were to calculate half of the shaded part, I mean, is half of the PQRS rectangle, 245, minus the left side of the rectangle, 98, and this will give us 147 centimeter square. Right, there you go. That's how you answer question 9B. Question 10. Linda baked some blueberry and chocolate tarts. At first, the number of blueberry tarts was 2/3 of the number of chocolate tarts. 1/4 of blueberry tarts and 4/9 of the chocolate tarts were given away. The number of chocolate tarts left was 12 more than the number of blueberry tarts left. How many tarts did Linda bake? So the first statement says at first the number of blueberry tarts was 2/3 of the number of chocolate tarts. So that means blueberry is equal to 2 units and chocolate is equal to 3 units. Pretty straightforward. The next one is 1/4 of the blueberry tarts and 4/9 of the chocolate tarts were given away. So blueberry given away is 1/4. That means blueberry left, not 14, 1/4. So blueberry left then be 1 minus 1/4. This will be 3/4. What about chocolate? Chocolate. So chocolate given away is 4/9. And then chocolate left is 1 minus 4/9. This will give us 5/9. So in this case, blueberry left in terms of fractions 3/4. We want to find out the number of units. Basically, 3/4 times the total at first, blueberry at, which in this is 3/4 times 2 units. Okay, and this will give us 6 out of 4 units. Then for chocolate left, in terms of units, basically 5/9 times the blueberry, not chocolate at first, is 3 units. Therefore, it's equal to 5/9 times 3 units give us 15/9 units. So let's simplify everything. So this will be 6/4 units. This will be 3 out of 2 units. This is 15 out of 9 units divided by 3 on each side, or numerator, denominator, 5/3 units, or 5. So why we calculate what is left is because it says here the number of chocolate tarts left was 12 more than the number of blueberry. Essentially, it's just chocolate minus blueberry equal to 12. So we want to find chocolate left as blueberry left units will then be equal to, so chocolate, we have 5/3 units minus 3/2 units. That means this is 10/6 units minus 9/6. Makes this 1/6. That means 1/6 units equal to 12. How many tarts did Linda bake all together? So we want to find out 6 out of 6 units, or 1 unit equal to 12 times 6 is 70. So total here 5. Total units equal to 3 plus 2 equal to 5 units. 5 units equal to 5 times 72. This will give us 360. There you go. So the answer is 360 tarts. Question 11, part A. May and Anne each used the same amount of flour to bake some muffins and donuts. May made 108 donuts and had 640 grams of flour left. 96 grams of flour was left. The mass of flour to use to make 3 muffins was the same as that for making 4 donuts. What was the mass of flour used to make 1 donut? Alright, so one thing that the question didn't say is Anne made 48 muffins and had 1.96 kg of flour left. So this is what we called a simultaneous equation. So in this case, the mass of flour used to make 3 muffins was that the same of 4 donuts. So what we're going to do is we're going to just let M be muffins and let D be donuts. Just a easy short form. So now what this means from the statement is that we're going to have 3M, or 3 muffins, is equal to 4D, or 4 donuts. With that, let's go to the next statement that says May made 108 donuts and had 640 grams of flour left. So that means in an equation, the total mass that May used for the flour is basically 108 donuts plus 640 grams. Okay, let's move on to the next statement where it says Anne made 48 muffins and had 1.96 kg of flour left. So we want to make the units the same. So we were going to change kg to grams. And now with that said, total N is 48 muffins and 1,960 grams. So the thing is that, do we convert these two? Okay, but before that, we know that total May and N each used the same flour. So that means total May and total N is equal to each other, which means if we were to put in the equation, 108D is equal to 48m muffins plus 1960 grams. So the thing is that what algebra letter should we convert into? So this depends on what the question is asking. The question asks for one donut mass. So that means we want to convert everything into donuts. So we're going to convert 48m to donut. So since 3m is equal to 40 earlier that we mentioned, then we can just put 48m equal to 48 divided by 3 times 4, and this will give us 64d. Now we know that we actually have converted 48m to 64d, and from there we can just do the normal equation. So usually we will just minus 64d on each side. So remove 64d by minusing 64d on each side. This will leave us with 44d plus 640 grams. Now we can just minus 640 grams on each side of the equation, and this will give us 44d is equal to 1320 grams. From there, 1d is equal to 1320 divided by 44, and this will give us 30. So there you go. One donut is what we said here. D, or 1D is equal to 30 grams. So for part B, May and Anne decided to combine both their remaining flour to make donut. What was the number of donuts they could make all together? So the total remaining would then be equal to 1960 plus 640, and this will be equal to 2600. So total remaining flour. Then from there, we can just divide, since one donut is 30 grams. So most number of donuts is equal to 2600 divided by 30. And this will give us 86 with the remainder 20. So in essence, we can just round because we can't have a decimal place, right? Or 26. Let's put decimal place in. So 26, 2600 divided by 30 is 6.66666. So we round this to the whole number. This will then be equal to 86 because we can't have a 0.66 donuts. So the answer is 86. Question 12, part A. JKM and NKM are triangles. NKLM is a trapezium with NM parallel to KL. Find the angle NML. So to find NML, it's basically this red part over here that I'm going to highlight. So we know that from the question, NKLM is basically a trapezium, and what sides are parallel? It is NM to KL. So I see over here. So now the next thing is that since these two lines are parallel, that means the adjacent angles will add to 180. So NML over here, so NML, basically 180 minus what angle? So if you were to guess this angle over here, MLK, then you're right. So how do you find angle MLK? So angle MLK, pretty straightforward. It's basically 360 minus 305. This will give us 55 degrees. Let's see over here. So since MLK is 55, and we know that the adjacent angle adds to 180, that means NML, it's basically 180 minus MLK or minus 55, and this will give us 125 degrees. So part B, find angle JMN. So JMN is this highlighted angle over here in orange. Okay, so one part that they didn't show is there is a right angle over here, little right angle. So in the previous question, we managed to get the angle for NML. In this case over here is 125. All right, so in order for us to get this orange angle over here, what we need to do is to find two angles. The first angle is this blue angle over here, and then we minus the green angle over here. So this green angle, can we find this green angle? Yes, we can. So this green angle over here, basically 125 minus 90. Angle in green, NMK is equal to 15 minus 90, and this will give us 35. Okay, so we know this green angle is 35. The next angle that we're looking for is this blue angle over here. So how do we get this blue angle, which is JMK? It's basically, since this JMK over here is part of this rectangle over here, is JKM. So to get JMK, we have to have 180 minus 68 minus this angle over here. I'm going to make it in pink, which is angle JKM. JKM. So to find angle JKM, we need to find this purple angle over here, which is NKM. So angle JKM, which is in pink, it's basically 19 plus NKM. So NKM in purple. So can we find the purple angle over here? Yes, we can. Because earlier we have calculated this angle over here, which is NMK. And since this purple angle is inside this triangle over here, that means angle NKM purple equal to 180 minus 100 minus 35. And this will be equal to 45 degrees. That's what you see over here. So now we know this purple angle is 45 degrees. Then we will just work backwards, which is JKM is 19 plus NKM, which is 45. And this will give us 64 degrees. So this whole angle over here is 64. So now we know angle JKM is 64. Then we go back. We want to find JMK, which is the blue angle. So the blue angle is 180 minus 68 1 minus 64. And this is 48. And now the last part is, since we know this is the green angle, that means we can find out this orange angle that we're looking for, which is angle JMN is the blue angle JMK 48 minus NMK, which is the green angle 35, and this will give us 13 degrees. Okay, there you go. So that's question 12B. Question 13, part A. The pie chart shows the favorite sports of all the members of a sports club. The information is also represented by a bar graph. The bars for tennis and softball are not shown. What is the total number of members in a sports club? So the thing is, how do we get the total number of members or everyone in the sports club? So the thing is that we know that swimming go to 1/4 of the sports club. Therefore, if we can get swimming, we can get the total. So for swimming over here, if we were to first look at how many gaps before the first number, so we have 1, 2, 3, 4, 5. So first 5 gaps equal to 10. 1 gap is equal to 10 divided by 5. This will be equal to 2. So from here, we can look at how many swimming, and badminton is also 1/4. So if we can get swimming and what do you call this, or badminton, then yeah, pretty straightforward. So badminton is 1/4. So that means since badminton is equal to 60, that means 1/4 of the sports club is equal to 60. So 4 out of 4 sports club can be 60 times 4. This will be 240. Right, there you go. Pretty straightforward. So question 13, part B. What percentage of the members chose basketball as their favorite sport? Since we know the total is 240, the next thing is we just need to find out how many people chose basketball. So basketball over here, then we scroll up. So we have 30. So we have 1 gap, 2 gap, 3 gap. So basketball is equal to 30 plus 3 gaps times 2. And this will be 36. Therefore, the basketball percentage then be equal to number of basketball divided by total members times 100%, and this will be equal to 36 divided by 240, or out of 240 times 100%, and this will be equal to 15%. Right, there you go. So question 13, part C. The number of members who chose tennis as their favorite sport was 1/3 of the number those who chose softball. How many members chose tennis as their favorite sport? So from the earlier questions, we know basketball is 36, badminton is 60, and swimming is 60. We can actually find out tennis and softball. So tennis plus softball, according to this, the number of members who chose tennis, 1/3 of the number who chose softball. So that means tennis go to 1 unit, softball go to 3 units. So tennis plus softball is equal to 1 plus 3 equal to 4 units. And then we also know how to get tennis plus softball is equal to total minus badminton minus basketball minus swimming, and this will be equal to 240, and minus the badminton is 60, minus the basketball is 36, minus 60, okay, and this will be equal to 84. Since we know softball and tennis over here in units, that means 4 units is equal to 84. Now we're looking for tennis, and tennis is how many units? 1 unit. So 1 unit, which is tennis, is equal to 84 divided by 4, 2, 4. And this will be equal to 21 members. Question 14. Part A. The table shows the ticket prices for a theme park. Ramu bought 3 adult tickets and 5 children tickets. What was the least amount he could have paid? So usually we just want to get the bundled deals. So 3 adults then plus 5 children. So that means for deal then be 2 adults plus 1 child. Deal A equal to 1 adult plus 1 child. That means we have deal B plus A equal to 3 adult plus 2 child. So remaining then be equal to total minus deal plus A. So the total earlier is 3 adults plus 5 children and minus 3 adults plus child, but and that gives us 3 children. So this means 3 children is equal to 3 times 15, which is $5. So total cost paid is equal to deal A plus deal B plus 3 children. This case is 54 plus 35 plus 45. This gives us 134. Right. Question 14, part B. Timothy purchased his tickets online and enjoyed 10% discount. He bought 4 tickets and 3 children. What was the least amount he could have paid? So the total he got was 4 adults plus 3 children. In this sense, we actually can have 2. So 1 deal B is equal to 2 adults plus 1 child. 2 deal B is equal to 4 adults plus, so this is not 2 child, sorry, 1 child. And this will be 2 child. Okay, so remaining then be equal to total minus 2 deal B. In this case is 4 adults plus 3 children. Okay. And then we minus 4 adults and 2 children. Bracket this. Always bracket them. And this will give us a remainder of 1 child. So total paid without 10% discount is equal to 2 deal B plus 1 child. And this will be equal to 2 times 54 plus 1 child is 15. And the answer to this is $123. But we got a 10% discount. So that means total paid with 10% discount. It's basically total times 100 minus 10 cent. That's the discounted price. Total paid. And this will be 123 times 90%, and this will give us $110.70. Okay, question 14, part C. Mr. and Mrs. Tan went to the theme park with their children. They spent $99 on tickets. How many children went to the theme park? So we're going to assume since there are 2 adults, which are Mr. and Mrs. Tan, therefore we can say that they bought deal B. So that means total spent is equal to $99. The remaining is basically total spent minus deal B. So 99 minus 54, and this will give us $45. Since $15 is equal to 1 child, $45 is equal to 45 divided by 15 times 1. This will give us 3 children. So total children is deal B child, or 1 child plus 3 children. This will be 4 children. So there you go. It is 4 children. Question 15, part A. Nisa bought an equal number of apples and oranges. He exchanged 48 apples for the same number of oranges and gave away 100 apples. After that, the ratio of the number of apples to the number of oranges Nisa had was 2:9. What was the total number of fruits Nisa had in the end? Okay, to solve this, we actually need to find out what type of question this is. So you can see that in this question, there is a ratio and we have a before within 2 items. So before is equal number of apples, and then she exchanged 48 apples for the same number of oranges. So this was changed, and then we have after. So this is what we call the before, change, and after table. So we're going to go through each of the different rows over here. So the first one, it says Nisa bought an equal number of apples and oranges. So we put 1 unit over here. Now the next part can be quite confusing. So in this case over here, it says she exchanged 48 apples for the same number of oranges. So that means oranges, we exchange, we minus 48. And that means oranges, we add 48. But there is a second part of this statement over here. This gave away 100 apples. What I see over here. Therefore, the apples is not only minus 48, but is actually minus 148 because we lost 48 to changed to oranges, and we gave away 100 apples. Therefore, it will look something like this. So now how do we solve this? So there is this concept that is called the everything changed concept. So we have even a same number of apples and oranges, but everything changed literally. And then we have 2 is okay. So the number of apples and oranges when it's changed is different. So what we need to do is we need to change the apples and multiply the after oranges. So that means 1 unit minus 148, and then we cross multiply with the after 9. And then we have to put the equal sign to change oranges. 1 unit plus 48. So before, right, we add 48 to multiply with the apples after. So then it will look something like this, right? So this is a bit more advanced, but essentially when you do this, the equation that you see from change, you must put it into a bracket. And then when you multiply it, you multiply both numbers in the bracket, or both things in the bracket. So it looks something like this, right? 1 unit times 9 minus 148 times 9. And then 1 unit times 2 plus 48 times like this. Then if you were to just simplify everything, this will then become 7 units equal to 1428. Then we can just calculate for 1 unit, which is 204. So the thing is, the question is asking, what was the total number of fruits Nisa had in the end? It's actually the change over here, not 2 is to 9, because 2 is to 9 is a different number and it's not unit. So apples in the end is actually 1 unit minus 148. That means 204 minus 148, this will be 56. Then for the oranges in the end, it's basically 1 units plus 48, because we added 48. And this will be 252. Therefore, the fruits in the end will then just be the apples in the end plus the oranges in the end. And this will be added to 300. Right, so let's go to question 15, part B. She then packed the remaining fruits into as many bags as possible. The ratio number of apples and number of oranges in each bag was 4:5. How many oranges were left? So we've already calculated how many oranges are remaining and apples as well. So the next thing is we need to find out how many bags are there. So we know that 1 bag of apples, according to the statement over here, the ratio number of apples to oranges is 4:5. That means we can take it as 1 bag of apples is 4. So that means if we were to calculate the number of bag of apples is what was in the end 56 divided by 4. This is 14. Cannot go more than 14 for obvious reasons. So for this, since we know the ratio is 4:5 and we know the number of bags, we can actually just multiply 14. And this will give us 56, which is what was left. But the thing is that for oranges, not exactly what we have the end, not 252. It's actually 70. So therefore, we need to actually find out what was left unpacked. So we can't just have 252 divided by 5 to get the number of bags, because we only can contain 4 apples is to 5 oranges in each bag. That's why we have a that's why we have oranges that's left unpacked, which is what's in the end 252 minus 70, and this will give us 100. And question 16a, there was a total of 28,040 centimeter cube of water in rectangular tanks X and Y at first. The height of water level in tank X was 8 centimeter more than that of tank Y. Find the height of water level tank Y. So for this, I'm going to show you an example to make it a little bit easier to explain. So let's say we have a total of 1000 centimeter cube, and we know the base area for X and Y are the same. So reason why I put the same is because it's easier. All right, so since we know the total is 1000, the difference is in terms of height is 8. So what we want to do is we actually need to find the height of X, because X has more. In this case, since the base area is 100 and the extra water that is more than Y is 8, is just 8 times 100, which is 800 centimeter cube. So we will calculate the remaining 1000, which is the total at first, minus 800, and that gives us 200. So this 200 centimeter cube has equal height for each y and x over here. So then how do we calculate the height for both x and y since we have the remaining 200? It's the same thing as how we calculate height from volume and base area. We just combine the base area together to get a total base area of 100 plus 100, which is 200 centimeter cube. And then, 200 centimeter square. That's the total base area. And the remaining 200 centimeter cube. From there, we actually can get a height, which is total volume divided by total base area. 200 divided 200 is 1 centimeter, right? So that is how you calculate in this kind of question. So from there, we actually can just follow the exact steps. First one is we know the total is 28,040 centimeter cube. So I just write the height equal to volume divided by base area. So we need to find for both base area, tank X and tank Y. So for base area of tank X, pretty straightforward. It is 35 times 22. It will be 770. For base area tank Y, it will just be equal to 18 times 18. It is 324. Then earlier I mentioned that we have an extra 8 centimeter height. So you might be thinking, hey, the base area is different. Can we still follow the same steps? Yes, because it will work. Mathematically proven. Okay, so from here, we need to remember the next step is to get the volume of tank X, the extra height. So how do we get that? Is the big base area of tank X, which is 770, times the height that is extra, 8 centimeters, which is 6,160 centimeter cube. Then from there, we actually need to get the remaining. So we know the total from the question is 28,040 and the extra is 6,160. So if you minus, it will be 21,880 centimeter. Then with the remaining, we can actually get the total base area. So remember, we get the total base area. So we combine the X and Y total base area, even though they are different, it will be equal to 1094. From there, we actually can get the height of Y, because in the earlier example, X and Y, after we remove 8, both have the same height. Same goes to these two tanks over here. So that means height of Y, since the height of Y is not plus 8, we just divide the total remaining water minus the total base area. And this will give us 20 centimeters. So now for part B over here, it says Kenneth poured some water from tank X into tank Y to fill it to the brim. So what was the percentage decrease of tank X? Round your decimal place. Okay, so from here we actually can solve it. So we know that tank Y is 20 centimeters that has the water. So what's remaining is this part that does not have water. So we need to calculate that volume because that's the volume that's being filled up. So the first thing that we want to do is we want to get the height of water to fill tank Y, which is basically total height 35 minus the initial height 20 is 15 centimeters. So the water poured to tank Y from X is basically the remaining water to fill up tank Y, which is the base area, 324, 18 times 18, and the height remaining, which is 15. This is 4,860. So the next thing is we also want to find the initial height of X, because we want to know what's the percentage decrease of volume of water in tank X. To get the percentage decrease of tank X, what we need to do is need to get the water poured divided by initial water in tank X times 100%. If I put X again, it will look very multi 100%. So we need to find the initial water in tank X. So therefore, we need to get the initial height of tank X first. Since we know tank Y was 20 at first and X was 8 centimeter more, it's just plus 8. Then from there, the initial water in tank X then just be the height times base area, which will be 21,506. Then from there, we actually can get the percentage decrease. Since we know the initial height, we know the water poured in tank Y as well. So that means we can just calculate, which is the water poured in tank Y was 4,860. Yeah, 4,860 divided by the total initial water in tank X divided by 100%. And we need to round it to one decimal place, which in this case is 22.5%. So question 17, part A. The figure shows 3 overlapping quarter circles and 3 overlapping squares of different sizes. AB equal to BC equal to CD equal to DE equal to EF and equal to FG. The area of the unshaded part in figure DGHL is 48 centimeters square. Find the length of DE. Okay, so in this case over here, since we know that DE is a square and it has equal heights with EF over here, that means squares are the same sides. This part over here, or this unshaded part, is actually just 3 squares. So from there, if we know that, that means the unshaded part is 3 squares. And we can get 1 square, which is equal to 48 divided by 3. And this will give us 16 centimeters square. Then the thing is, D is one side of the square. To get one side of a square, we just want to square root the square area. So that means one side of the square, or DE over here, is basically square root 16, which is 4 centimeters. So question 17 part B, find the area of the shaded part of the figure. So the thing is that for the square, since everything is the equal sides over here, then we can just, chop them up and then just count the number of squares or shaded squares. So it's actually pretty straightforward because we've calculated one shaded square, which is 16. We calculate the number of squares. We were to count them. It is 6 shaded squares. That means the total shaded square area is 6 times 60, which is 96. Now the next part is we need to know the quarter circle over here. So to get this quarter, and since it's overlap, we just have to get the bigger one minus the medium one plus the smaller one. Or the easiest way is to just add the big and small minus the unshaded quarter circle, as what you see over here, which includes the smaller, so it overlaps itself, right? So it's actually not one length. What you see over here is actually 2 lengths. So that is the unshaded quarter circle. So to get the big quarter circle radius, since we know one side of this line over here is this part, then we can just multiply accordingly. So from here, we can actually just write big quarter circle is equal to 4 times 3 because there are 3 lines. Then from there, we can just get the big quarter circle area. So remember to always put the 1 quarter because we are calculating the quarter circle area. And then times pi times radius times radius. So the big quarter circle is 113.04. Then we want to grab the small quarter circle radius because it's only one shaded part over here. Then we can just calculate it. Small quarter circle is 12.56. Now the last part, if you have not done overlapped shapes to find the area, so we actually need to get this area because to get the shaded part, we need to get this whole area minus this small area. So that's why we need to get 2 of the lines over here. 1. So that means the unshaded quarter circle radius, not 4, but 8, 2 of the line. Then for the unshaded quarter circle radius will then be equal to 50.24. And finally, to get the shaded part of the quarter circle, we can say that this this unshaded part minus this small shaded part, then we can plus big one over here. Or in essence, the big quarter circle plus small quarter circle minus unshaded quarters. And this will give us 75.36. And for the total shaded part, we can add 75.36 plus 96. Is what we calculated for the total shaded squares area. And this will give us 171.36 centimeters. That's it. So if you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below. Comment down what other things you want me to show you next. See you in the next one. Bye-bye.